Three more examples in this video. The instructions are simple. Take a derivative, differentiate. Have a function q of x, 2 sine squared of 3x. So again, let's remember that sine squared is really sine of 3x all squared. When I look at this function, I see an outside function, 2 times something all squared, and then on the inside I see sine of 3x. But when I'm just looking in there, I see another inside function. I think I'm going to have to use the chain rule more than once. So let's take that derivative using the chain rule as many times as we need to. So let's see. The power rule, 2 times something squared, the power rule would tell me that I have 4 sine of 3x to the first times. And now I need to take the derivative of the inside function. So I need to take the derivative of sine of 3x. Well, again, I have to think about the inside and outside functions. The derivative of the outside function is cosine of 3x times 3. And that should be written there, and I ran out of room. But now I have my derivative, and I can write that down a little more nicely. 4 times 3 is 12, so q prime of x is 12 sine of 3x cosine of 3x. If I wanted to, I could very cleverly rewrite this using that double angle formula for sine, but I'm going to leave it like that because the point of this problem in this particular video was sometimes we have to use the chain rule more than once. Coming to r of t equals secant of 5t squared, and I'm asked to take a derivative. So I need to remember that the derivative of secant is secant tangent. And here, just remembering the rule, I've used the variable x. My problem is going to use the variable t. All right, so I'm supposed to take the derivative of the outside function, which is secant, leaving the inside alone. Well, the derivative of secant is secant tangent. And I'm supposed to leave the inside alone, so whatever was on the inside of secant goes in both places. So that's a 5t squared, and this is a 5t squared as well, times the derivative of the inside is 10t. And I would usually write that down as 10t secant of 5t squared times tangent of 5t squared. I like writing the easier part out front, though it really doesn't matter. All right, and the third example here that I don't think I've left myself enough room for, so I'm going to move on to another board, was to take the derivative of y equals e to the sine of 4 theta. So here again, the idea is I have a function on the inside of a function on the inside of a function. This is an inside function, this is an inside function, and my outermost function is e raised to a power. Oh, let's see, this would be a dy d theta if I take a derivative. So I have to take the derivative of e raised to something is e raised to that something, times the derivative of what was in the exponent. The derivative of sine is cosine of 4 theta times the derivative of its inside function. All right, writing my final answer in just a nicer way, and I'm done. All right, so 3 more examples there of using the chain rule. In the next video, I want to look at some of the rules we know through the lens of the chain rule.